What's up guys, and welcome to the third video in my Pragmatic Data Science series. And in this series we're going to start diving into the data a little bit more and try out this Python application that I wrote. So first off, let's take a look at the data again, so we're in the updated how it actually looks like. So first we have this CSV header, and then after that all the data is separated by semicolon in this case. And so the first thing I need to do is read in this CSV file here into my Python application. So I'm just using a text editor like Sublime Text, and you can use like whatever you feel like using basically. And I'm using Python 3 for this, and I suggest you do the same thing because then it'll be the same. But I guess you can get away with Python 2 also if it's a problem for you to install it. But anyway, so I'm also going to be using pyplot here for plotting, and if you don't have this installed, you can install that with pip, like pip install and then matplotlib. And when you do that, be a little bit careful if you're not familiar with how Python's package manager works, because make sure it is the version 3. I usually use pip3 install and then matplotlib. But I already have it installed, so I'm not going to do it. So you need to have that installed, and the first thing we're going to do is we're going to read in the CSV data. So I have created this method here called read data that takes the file name and whether it's with headers or not. And in this case it is with headers because I have this first thing here that specifies the date, temperature, the name of the columns basically. And that is what that is. It's a defaulting to true here. So the first thing I do is I open up the file and read in all the lines. And this is fine for small data sets that we can fit in memory. And if you have a huge data set, you won't be able to do this basically, and you have to use other approaches for this. But since this is just a simple CSV file, this is fine. And then I strip out all the white space that might exist in the beginning or the end of each column and line. So I use the strip here, and then I do this thingy here where I iterate over the rows and I split each row into columns here, and you can see here I have specified the semicolon. If it is specified by comma, you just switch it out to the comma here, or whatever separator you might have. And then I just append it to this temp variable, and then I switch them out. And here, if it is with header, I return everything but the header and the headers. So basically I can do this. So I get the data and then I get the headers as well. And if you're confused how this works with Python, like the structure of this, because I personally get confused about this all the time. Usually what I do is, I hope you can see this, but I open up like my terminal and I fire up Python, and then I just do like this. So I create an array like this, and then if I'm supposed to be selecting 2, 3, 4, I usually do it like this, and then I test it out saying like, what if I do this? Okay, then I get everything but the first column. And what if I do this? Then I only get the first one, put a minus in there. So I test out all the possible combinations of this and see what that gives me basically. But yes, and when I have grabbed all the data, this is unformatted. So what I do, I iterate over each row, and I need to do this because there is some dirty data in there, that some empty rows and stuff that is missing temperature readings basically. So I have to check if it is actually there, and if it is, I parse it to float, because remember, this is when this is coming in, it is a string, so I need to parse it to a float. And also, if you remember from the data, I don't have any temperature average, I only have temperature min and max. So what I do here is I just sum them up and then divide by 2 in order to get an average temperature. And then the next thing I do is, in the first column here, we have the data, the date, so it's like year, month, day, and I need to parse that from a string to a date object. So for that I use datetime, which you need to import. but it should be coming from the Python library, so you should have it available to you. Then string to time for the first column of the row, and then this format where year is an uppercase, and then month, and then day, and then dot date. So this gives me a date object that I append to a dictionary here, which I call plot data. And one thing that I realized about the data is that, you know, these dates here, they're not sorted in any way. If you can see, this is the 3rd of October, and then the 10th of October, 14th, blah 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 blah, November, and then, you know, suddenly basically they're not sorted in date, I realized. And I need to do that in order for me to plot it properly. And I do that with lambda here, so I put in this plot data here. I sort it by the date here in descending order. And oh, sorry, I think it's actually ascending by default. If you want it, you can, in descending order, you can type reverse, I think like this, and then it is going to sort it in the other direction, basically descending. And now I just have a dictionary of all these dates and temperatures, and I need to parse that to arrays that I can use for the plot library here. So I just iterate over it again. I append the date and the temperature here, and then I use matplotlib here with plt, set the labels, and plot it, and show it. Now I know that you can make this more effective in terms of iterations and complexity here, but I don't really care at this point. I just want to make it as straightforward as possible in order for it to read it, so you can see all the steps. So I know, for example, that I'm making a 2-pass here where I pass the data twice. I guess you can make some other implementation to not do that, basically, in terms of performance. But at this point, it doesn't really matter. This is just for meta-analysis of how the data looks. So basically what I have done here, I've plotted all the temperatures over dates in a line chart. So if I do this and I run the application, I should be getting a plot that looks like this. And remember, this is in Fahrenheit, the average temperatures. And if we take a look at this of course makes sense. You know, the temperatures are of course following some kind of fluctuation here over the years in terms of seasons. So you can see here is like probably winter here. In January of 2008 it was really cold, and then summer hit, and then it goes down again to like the next winter. And yeah, for 2009 it's actually not showing here, but it is here, here I guess. And you can see January here, and then it keeps on following this pattern, right? So we're gonna use this in order to figure out how many people he's gonna have in the shop, basically, because, you know, in the winter he can be there all by himself selling ice cream, but like in the summer here, or especially on some years like, I don't know, like 2011 I think, it was pretty much a good year, because you can also take a look at the density of this, like how it's more dense up here, because, you know, even though I can't really zoom in this picture, but you can see it's not a proper straight line. It fluctuates up and down according to each day as well, so it's not a pure line where it's exactly the same temperature every day of the season. And what that means we're gonna take a look at in the next video, because that's where it starts getting interesting. Alright, so I hope you guys followed along here with the implementation of the code, and you can also download this from the GitHub repository. And if you have any questions or anything, just leave it in the comment, and don't forget to subscribe if you haven't already. Alright, see you guys in the next video.